Hi, I'm Greg Autry. I am the clinical professor and director of the Space Policy Leadership and Business program at Thunderbird School of Global Management at Arizona State University. I'm excited to be here in ASU's beautiful DC building, helping to host this fantastic summit today. And I've got a good friend I would like to introduce now. Dr. Ajay Malshe is the Goodwin Distinguished Professor of Mechanical Engineering at Purdue. And notably, he is one of the world's experts on in-space manufacturing and in-space assembly and manufacturing. He's going to be hosting an exciting workshop on semiconductor space manufacturing coming up in a couple of days. And in fact, AJ, I'll be flying out to see you tomorrow in beautiful West Lafayette. Promise me it won't rain.
I definitely promise you, Greg. We look forward to see you, and we had a great response. Many leaders in the no pun intended in the space would be there.
That's fantastic. So let's get right into space manufacturing. A lot of people probably aren't aware of that. I hear a lot of people at events like this saying we need to leverage the power of commercial in order to improve our national security, improve our economic development, create jobs, all these things. What does that really mean? You know, it's not about just launching things into space, because that doesn't really produce anything tangible. Space manufacturing might produce something tangible. Can you give us an overview of what's included there?
Absolutely. Greg, first, thank you for having me. I'm just delighted to especially work with a friend and a subject matter leader expert in the world. So thank you, Greg. Happy to be on the show with you. There are three angles that I would like to bring to the in-space manufacturing or in-space servicing, assembly, and manufacturing. Because what is important for America is what I would call resilient operations in space. Resilient operations in space. And how do you operate in any environment? If you think about the ground, offshore, any extreme environment or real environment for operations, you always need to make something, you need to serve something, and once you make it, you got to assemble something to make it work as a system. So manufacturing or assembly or servicing in space is a very important part of operating in space. That is number one. The second thing that America, as is going through a renaissance, what I call of manufacturing, we are reshoring, we are retooling, we are retraining people. Now we just need to add third axis to that. We need to be doing that for space. That we need to be, I wouldn't call reshoring, but we need to be sending people above the carbon line. We got to be training people. And if people would think space means you got to have PhD or masters. No, we need everybody to be a part of this commerce, which is lifting off. And the part of that, we need to retool. We need three types of tools. Physical tools, digital tools are very important, and tools, those are sustainable. But those are the angles to this of making, because it's a part of operating.
Well, fantastic. Can you give us an idea of some of the sort of products that people are or may soon be manufacturing in space, and what markets both on Earth and in space those might address?
Absolutely. There would be, I would call 3+1. One of the first thing is that making, so why to make in space? There are two parts. I mentioned about operation in space, right? We are going to have satellites, we are going to have stations, we are going to have tourism as a part of this. Remember, this is a commerce. This is a security at the same time. So we're going to have products, those are going to, the word exploit is probably not the best user word, but what I would say, take a benefit of this space condition. What does that mean? That we have abundant sunlight, we are going to have a microgravity. Because remember, on the Earth, we are driven by working in the gravity. We get so used to this in our lives that we don't even think the different. But in the space, you have no gravity or microgravity, to be accurate. You have very extreme temperatures as well. So you have many things, those are different than Earth. So you can do very unique chemistry experiment, very unique physics experiment, and then you can synthesize molecules, materials for biomedical applications that could be great for the human lives. So one area is called biopharma in space. The second is energy harvesting. As you would know, as the population is growing, abundance of energy supply is going to be very important for us. And we are going to need all forms of energy, not one, but all forms for resilience again. And for that, space is a great environment as an energy source to either harvest, transport, various forms of their supply chain, if I may call. And I'm going to start using the term intergalactic supply chain, because we are truly at that age of intergalactic supply chain. So energy is going to be a part of that intergalactic supply chain. And the third part of that manufacturing would be, which is going to be important, semiconductors. And people say, Ajay, why semiconductors? Because remember that if a human has to go to space, basic needs like food, habitats, energy, but at the same time, for us to operate, digits are going to be important. For those digital footprint, we're going to need a semiconductor. And 3+1, because that one is going to be what I call surprise, that we yet don't know. And that's what everybody's going to look for, that killer application.
That's fantastic. I like to point out to people that if you go visit a pharmaceutical manufacturing facility, what do you see? You see a lot of vats with a stirring machine stirring. And why are they stirring? Because the gravity is stratifying the heavier molecules in those solutions down to the bottom, and they're never getting the perfect chemical mixing that you could get, and they have to agitate them, which causes its own issues. In space, you can, as the professor noted, make molecules that are pretty hard to make on Earth, and you can make various molecules interact together in perfectly efficient ways, form perfect crystals that you can't make here on Earth. And in biology, you can get cells to grow faster and into more complex 3D structures. You want to make an artificial liver for somebody on Earth, you can take their cells, you can take their stem cells and differentiate them, force them to become liver cells and grow a liver pancake. But in space, you can actually make a vascularized organ that could someday perhaps save millions of lives here on Earth. So I'm so excited about that.
Greg, if I may add to that, what you just beautifully said. So one of the areas that we explored on Earth are nanoparticles, nanotechnology. And nanotechnology in space without no gravity is going to make nanotechnology brilliant for many applications, including biopharma and therapeutic, what you just described. But another thing I would like to point out, that now we are walking the age of quantum devices, qubits, and making nanostructured qubits, semiconductor quantum devices in space is another very important area that we see in the future to grow. But thank you.
Yeah, I mean, Moore's law is something probably everybody knows about now, and that we're able to increase the density of semiconductors in a 2D matrix, but we're really reaching the atomic limits of that. And so at some point, you've got to go quantum and you've got to go 3D, and space gives you some really unique opportunities there. Let's talk about ISAM again, then, and specifically on power. You mentioned power delivery to Earth. How would manufacturing in space assist with that versus building solar panels here on the ground and lofting them into orbit?
So there are three parts to that. First part, I would say that when people talk about operating in space, there are two ways one need to look at that: operating in space for Earth applications and operating in space for space applications. Now, when you're operating in space, there are two other parts to that: operating in orbits like lower Earth orbit, LEO, what people fondly call, or operating on the lunar surface or any extraterrestrial surface. So that would be a ground. So those are different conditions. Also, speaking about this, speaking from Earth, one may imagine that these distances are very short. They are not. They're very far distances. So we need to start thinking about manufacturing at point of need, PON. And for example, towards that, if we are going to start manufacturing in space, what kind of platforms we need, what kind of manufacturing facilities we need. So people call manufacturing platforms, manufacturing factories in space. That's how I got very early in my career. Or also you might call the ports. We are going to need ports or distribution centers. So exactly what we have on the Earth, but it would take a different form factors, different supply chains, and different vocabulary digitally and physically to work with it. But it does need to all tie up together. And we are at that early age of golden rush, what I would call the space rush.
Yeah, a lot of people, for instance, are, I think, intrigued or inspired by Elon Musk's vision of, occupying and maybe someday terraforming Mars. But if I'm an early Mars settler, I don't want to click on my Amazon Buy Now button and wait for a year for my products to show up. And in particular, if you've got something like a maintenance med, you need to take an acid suppressor, or you need eye drops because you have dry eye or something. Some of those products might not even survive the transport time. People with antibiotic needs, we're going to have to be able to do these things, and we're going to have to be able to do them fairly soon, or you're going to restrict this population to a very small group of people. So that's exciting.
So Greg, this is about to change in space, very important, because on Earth, one of the things in manufacturing we are quite used to is centralized manufacturing. Centralized. Means when you look at automotive manufacturing, it's all centralized at one location. We ship it everywhere. That is about to change in space, because space being such a vast ecosystem and environment, manufacturing at point of need, where you can manufacture, assemble, serve, and operate at point of need, and then connecting those nodes is going to be a very different platform that we are used to Earth. So point of need manufacturing or convergence of manufacturing is something important.
Do you think some of these technologies that will be developed for a space application will come back and benefit manufacturing processes here on Earth in the future?
Oh, absolutely. There are a few ways that this is going to change. Number one, that, as I mentioned earlier, that microgravity would be applied to make some of the unique therapeutic molecules that we can't make it here. That would help to cure many diseases that we know, and as population is aging, that we don't know even at this point in time fully. So this would be imagine that we have now a laboratory away from Earth, but just close enough that we can make unique materials, unique processes that we can benefit large population on Earth. Number one. The second thing, that this would also benefit the Earth in many ways. That think about, this might sound completely crazy in some sense, but you have hotels on the orbit that you can go and take a vacation, that I'm going for my spring break, maybe in an orbital hotel. So this is going to open a human mind, because how human race have progressed, that our imagination as it expanded, we made it possible. So going to space, just the habitation is going to open our minds to infinite possibilities. So that would be a part of progression of human race to the imagination. The other parts of that operation would be that how we will operate in space, and the technology that we will build, like point of need manufacturing, can then brought back to the Earth to advance our learning on Earth. So it is going to expand our learning field in the summary.
No, I think you're absolutely right, and I don't think you're crazy, AJ. I'll be up there at the Space Hotel with you someday soon, I hope. And you're right about technologies in space coming back. If you think of solar power, for instance, the first customer for solar power, it was really the United States government on America's second satellite, Vanguard, which used solar cells, and it turned out that worked. And the driving force behind making higher density, lighter weight, and higher performance solar cells has been space applications for 50 years. I probably wouldn't have solar on my roof charging my electric car if we hadn't have made that investment, both at DoD and in NASA, in doing that. And it comes back and benefits everyone.
So Greg, you asked me, just a second, you asked me a question, and that I just remembered that I have not fully answered. So to add to your question on the energy, I would like to only point out that our energy supply chain is going to expand. We would have mobile energy that we would store, transport, reheal, recharge, again transport. So we have mobile energy. And then second thing, we'll have great source that we can leverage to distribute across Earth at different points of need. I just wanted to add that to the point for the energy supply chain.
Yeah, you're absolutely right. People are talking about building large structures in space in order to beam power as a microwave laser back to the Earth in order to power cities without having to disrupt a great deal of land with low energy density solar panels. If we were to build something like that, would the resources that are actually already in space be a benefit? Are there things on the moon or asteroids that will allow us to do that? Are we going to have to loft all this stuff off the Earth in order to do this manufacturing?
There are a few scenarios, and probably the time is going to decide that. Because what is going to decide is that at a given point in time, how the business model are going to meet with the price parity. That's what's going to drive. And there are going to be different phases of that. At this point in time, that we are lifting everything from Earth and we are sending it and leaving the gravity. Even today is expensive. It is getting much better, but it is still expensive. So at this point in time, probably building a manufacturing platform on lower Earth orbit or some locations like those would be going to be important, that we ship some of the basic materials that we're going to need, and then we assemble that. And why we assemble that? So we can service it. So say, for example, you have energy stations in the lower Earth orbit or other location. You need to serve them from time to time if they get damaged by micrometeorites or other objects. Then, so it's good to start with servicing, assembly, and manufacturing rather than manufacturing, assembly, and service. So service industry is going to be driven by assembly and then coming by manufacturing. So initially we may have to see that with price parity, what things we can ship, what things are going to be difficult to ship, what are the new business model where the hardware will be free and the software will pay for that. And those business models that people don't talk much, but they're going to evolve with the manufacturing systems, materials, processes. And that so manufacturing and operations with business model has to come together.
Right. But let me push you a little more on the space resources issue. Do you think it'll make sense someday to have extraction on the lunar surface and put some of this space material into space from the moon in order to manufacture it in space?
Yes, I think, for example, what people fondly call a regolith, means if we're going to have a habitation, this Artemis mission everybody's excited about. So if we're going to have habitation on moon, how are we going to build it? So remember, when America went from the East Coast to West Coast, what we did, we maximized the available local resources, what we had available. Now we're going from here to moon. So we're going to say, what are the resources available on moon? Water, that if we split, is a good source of energy. So water is oil on moon. For example, the regolith, that if you take that regolith and can make a sustainable habitation out of this with the unique designs that are required, that is a resource that we have there. So again, the definition of word resource on Earth is going to be very different than definition of word resource on the moon. But we will be relying on local resources. Those are available as a generation 1.0. Now, once we station that, we stay there, we grow there, started thinking about, then we will see how to take that ore and from that find the unique ways to extract advanced next generation material. Remember, human race started with the Stone Age. We didn't extract anything from stone, but as we progressed, we went from Stone Age to Copper Age to Bronze Age to Steel Age. So we advanced our processes to explore and apply the local resources to make better and better out of it. And I believe that that's what would happen in moon, but we're going to start with the basic resources, those are available now, and start building the parts and processes with it.
And for those that don't know, regolith is moon dirt, basically dirt without the organic matter in it. It's a notoriously troublesome product for astronauts that have been to the moon, and it may be actually something of benefit. How would we take this material and turn it into a construction material?
So there are companies already looking at that. For example, if you take a regolith, which is just as you say, dirt, only the difference between dirt on Earth and dirt in moon is this very expensive because it's just difficult to get there. But if you take that dirt or regolith, much more sophisticated word, I would say, combine that with certain base polymeric material, and then you create an amalgam or a mixture of that. And if you can 3D print the housing, or 3D printing, what I would use the word habitation out of that, that is very doable at this point in time. And companies, as I said, we are already 3D printing civil structures on Earth, and companies are now starting to look that if I do want to have something like this, first, how can I excavate? How can I take it from the Earth? Then how do I granularize it? Once I granularize it, what binders I will mix with? Once I mix with that binder, once I put it there, because remember, on Earth, I can mix cement with water. On moon, there is no water. So I need to think differently, but the thinking mode would remain the same. The materials would change. And then which material I mix it with? Is it affordable to mix with that material? Where the material is going to come from? Now, once the material settles down, what is the curing time? If there is a word curing for that, for example, or can I just set it up there? So what kind of design I can bring so it can withstand some of the very difficult environment and protect the human inside. One of the things that one need to be careful, we're just coming out of pandemic. So how this housing can be antimicrobial in a sense of bacteria and viruses. So these are all beautiful questions going to come from how we address it. And that's what I was saying, that once we learn how to do things better and in more severe condition, it is going to help us develop more respect for Earth and do the things more sustainably on Earth.
Great. And if I might, I'll plug a paper I just did with Professor Phil Metzger at the University of Central Florida on the economics of producing lunar landing pads using a polymer resin infused in regolith and or sintering, which is basically just baking the lunar soil using high-powered microwave systems. If you're interested, that paper is in the New Space Journal, and it's a free download right now. So as we wrap up here, tell me your vision of the future. Where do you think we'll be in, say, 5 years? Do you think that any of us will actually see some sort of product that we've held in touch that was manufactured in space? And then where do you think we'll be 10 or 20 years from now with space manufacturing?
So, Greg, this question is always exciting, right? We are imagining and we are very optimistic about it. So one thing I must share that my view of space is probably you may call borderline dangerous optimist. And in a truthful, I mean, this is what one is asking me a question in 80s, that where the internet would be. And imagine if in 80s, if we would have thought that we're going to have LinkedIn's, Facebook's, Google's, routers, voice over IPs, means that would have been called dangerous optimism by in 80s, right? If I would have talked like this, two computers connected with wire. If that was that simple, but very so powerful by then, imagine that now we escaping the gravity, leaving the Kármán line and going above and now expanding our horizon from imagination to productization to learning how to live in the extreme environment. So humanity, as we will continue to carry beyond the Kármán line, I think that we are going to see the products that we even cannot imagine today. We are going to come up with the practices to live human life on Earth and beyond Earth that we don't know today. But as long as we continue to follow the best humanity practices, I think it is going to be a great ecosystem. But as I said, I'm going to be there to live this for next 5, 10, 15, 20 maybe years of life. But I believe that I would see human being residing in space in my lifetime pretty soon.
Well, I'm excited to look forward to that future and join you there. And I'll be joining you in Purdue on Thursday. Thank you so very much for your time. I greatly
If I may put a
it.
plug in
Yes,
this conversation in conclusion. So on Thursday, with the support of many key invited leaders, including Professor Autry and others, about 80 to 90 people, the world's first in-space manufacturing of semiconductor road mapping for trains and drivers workshop we are hosting at Purdue. And Purdue is a very special place. We're going to host our colleagues at Neil Armstrong Hall of Engineering, and they're going to see a lot of memorabilia around. But the purpose of this is that to allow to find commerce and opportunity space and gaps where people can work on and invest and grow commerce. So we're going to have businesses, governments, and academia, about world's 80 to 90 experts in America working on this. So looking forward for that, hosting all, and it's a great place at Purdue. Space is very fond. Manufacturing is we call boiler makers, and semiconductor and microelectronics is absolutely one of the top priorities. So we look forward to Greg, but thank you again.
All right. I'm looking forward to it too. And if anybody's interested in this very building here in Washington, D.C. on November 5th through 9th, I'll be hosting a executive certificate program in space leadership. We'd love to have you here. I know we'll have a number of participants from government agencies, both here in the United States and around the world, as well as folks from the private sector that want to learn more about what's going on in space. You can find that at the Thunderbird School of Global Management website. Thank you.
Well, thank you. Thank you, Greg. See you soon.
See you soon.